Hey kids, we are going to do lesson 30 today, and this is a really important and super cool lesson with dividing decimals, and the objective is to divide decimal dividends by non-unit decimal divisors. So what does that mean? It means that I have like a whole number, and I will have a decimal divisor, which we can then turn into a fraction, okay? But we're going to learn how to leave the decimal in it and what can you do with this. And so there are a couple different things. I've got like the old-fashioned way and the shortcut, but it's kind of like, why does this work? So that's always my favorite thing, is when something will finally click. So I've got a couple different sets of notes, so I'm going to go through this real quickly. But if I have a whole number and I have a divisor that's like a 2/10 and I could turn it into a fraction, what is the scale factor that I could use? So this looks weird, and you can use scale factors, but in the book there's this big dialogue between the teachers and the kids, and it never seems to work out quite right. Some kids will get it, but some kids won't. And so, yes, you can scale using many different fractions that equal 1, but you won't always have something convenient that is at the ready. So let's take a look at these notes. I think these kind of explain it a little bit better, but we're going to talk a lot about this. The divisor controls the decimals. So what do I mean by that? So let's say I have a problem like 34 8/10 divided by 6/10. This is the divisor, okay? Turn this into a fraction. 34 8/10 divided by 6/10. Same problem, just in fraction form. The divisor is going to control, it's going to do the driving, okay? The divisor does the driving. If I have tenths, I'm going to choose tenths as my scale factor. And I'm going to multiply both the top and the bottom by the same number. Now, why do we do this? So this is my own interpretation. When I look at this and I say, well, what if I wanted to just set it up and have the decimal in this number out here? It can be confusing. Where would you put your first digit? Is it 34 ones divided by 6/10? Should that be a tenth? Should it be a ones? So it can be confusing about where the decimal goes. So the math people who decided that this is a good strategy said, hey, gosh, look what we can do. Because this is a fraction, if we change both numbers at the same ratio or rate, we get the same relationship between the two numbers, and then we don't have to deal with the decimal. So that's why the divisor is always going to be the driver. This one's going to decide what the power of 10 is that we're going to multiply it by, so that we can get that decimal out of the divisor. You can have one in the dividend, that's fine. We just know that we're going to put it up when it finally lands in its landing place. Okay, so the best example of that is down here. Now, what if I have offsetting decimals? So I have 4 55/100 divided by 7/10. So how do you decide which one to choose? Should I use hundredths? Should I use tenths? Well, remember, the divisor is in charge. And I have lots of students that'll say, I want to do hundredths because they see 2 digits here. You can still do that. What's going to happen is you're just going to have to do a little bit more division work, and frankly, nobody likes to do division work. So if you change it by simply multiplying by 10/10, what you do is you get the decimal out of the divisor. This is now 7. You can divide 45.5 by 7 and get your answer of 6.5. You can do more work if you want to. It just makes the problems a little bit bigger. But do not change the ratio between the top and the bottom. Critical, very important. Notice, big X, that's a no-no. Never, if you're going to have a scale factor, never have different numbers on the top and the bottom. You must have the same change happening to both the top and the bottom. Okay? Now, that's probably all confusing. You're like, what? I don't understand what I'm doing. That's okay. We're going to practice and you will catch on. All right, so here we go. So open up to lesson 30 problem set on page 307. Also, I notice sometimes I'll be going over these with my students and they'll say, I have a number 3 there where you have a number 5 in your book. That was a few lessons ago. And I was like, well, I don't know. I can only do what I have in my book. If yours has something different, you do what's in your book. But I think it was a misprint in the kids' books. So anyway, let's get to it because this is kind of a long video. Oh, I'm going to run out of lead. Okay, so they give us an example, and they've been started for us. So we're going to just talk through and see what we're doing. Take the decimals, turn them into a fraction. 2 7/10 is being divided by 3/10. Take it and take this fraction form and multiply by the scale factor. Remember, the divisor is in charge. Okay, and the divisor is in charge of the power of 10 that you are going to choose. If it's tenths, you get tenths. Once you multiply by 10/10, look at how convenient that is. It just moves the decimal right out of the 2.7, turns it into 27. And it also, critically important here, moves it away from the 3/10 to be 3 ones. And now I have a problem that has the same ratio. So whether I divide 2 7/10 by 3/10, I will get 9. Or if I do 27 divided by 3, I will get 9. So it's just easier to do whole numbers instead of using decimals. It's just easier. So everybody moves that decimal out of the divisor, get rid of it, and then you can do simple division. Here's another one. Same numbers. Look at they have the connection between the numbers, so you don't really have to think about the facts. Write it in a fraction, 2.7 divided by 3/100 this time. Now, we have different decimals offsetting, but who's in charge? The divisor's in charge. This one has 2 places, so you're going to have 2 zeros. Okay, so if however many decimal places you have to the right, you've got to have the same number of zeros so you can get it out. So when you multiply 2.7 times 100, notice I now have an extra 0 here because it's not just multiplying by 10 to give me 27. It's by 100. Like that's going to be a really important thing. You got to keep an eye on how many zeros. So 270 divided by 3, we already know that it's 9 because we did the math over here. But now I have 27 divided by 3. That's the 9, but I still have this place value position that's being divided by 3 as well. So if I set it up like this, you'll see it here better. This is where the 9 goes, but I'm not done. Okay, you have to finish this in the ones place. Otherwise, you just leave it hanging and it's incomplete and wrong, and nobody ever likes to get them wrong. Okay, now let's jump in. They didn't give us any scaffolding, so we have to figure out what to do. We have to make the pencil work. 3.5 divided by 0.5. Let's take this, and remember, just put the equals. 3.5 times what? And so who's the driver here? This is going to be the denominator. So since there's only one place value position there, we're going to have 10/10. That's going to move the decimal out in both, so that's going to give us 35 divided by 7, and voila, the answer is, 35 divided by 5. I think I'm thinking ahead, and I'm like, ta-da, look at that, I just wanted to give you the answer. So 35 divided by 5, 35 and 5 equals 7. Let's do it again, but with different numbers in our fraction. 3.5, and now I have a 0.05. So this divisor is in charge. 2 places, therefore 2 zeros. Okay, you got to choose the appropriate number. Oh, geez, do I really? Okay, this is our fun for today. I'm going to run out of lead. And 3.5 times 100, so I need to go 1 and 2. So you're going to end up with 350 over 1, 2, 5. And that's where you're going to get 70 for your final answer. And I feel like I have no... How fast can I add lead to my pencil? Here we go. It's so fun making videos because this is what we do in class. I'm like, okay. All right. Anyway, moving right along. Happy day, everybody. Okay, now at least when it poops out, I have more in there. Okay, 4.2. Let's get this one out and get the next one in. Yay. Sorry for the delay. That's life. That's life. Okay. 4 2/10 divided by 0 7/10. And then the phone goes off. I'm having fun today. How about you? And so the divisor is in charge. And because it's tenths, we're going to make times 10 tenths. Now, when each one is multiplied by 10, I get 42 divided by 7, which gives me 6. Let's move on faster since I've had problems and I want this to go faster. 0.42 over 0.07. Now that that's our fraction, we have to figure out who's doing the driving. The denominator is 1, 2, 1, 2 zeros. 100 is our factor, and so it's going to be 42 over 7, which again is 6. Okay? Now I'm really cruising. Now I have lead in my pencil, and I have 2 more pages to do, and we can do this because this is actually going to go really fast. Hopefully it will focus very soon. 10.8 divided by 9/10. Again, this is just more practice. 10.8 over 0.9. The divisor is in charge. 10.8 over 0.9. I have tenths in the divisor, so I'm going to choose 10 tenths. Always the same number. That means move it once, 108. Move it once for 9. 108 divided by... Oh gosh, yes. You know what? I'm making a video, and of course, making a video. Why are you bothering me? Sorry, I had to text. Okay. 108 divided by 9. And it's like, people, just leave me alone. 9 goes into 10 one time with 1 left over for 18, and then that leaves us with 12. Let's do it again. 1.08, but without the phone calls and the pinging me. Okay, 1.08 divided by 0.09. This one's in charge. We need a factor of 100. 1.08 times 100 over 0.09 times 100. 108 over 9, because times 2 zeros, times 2 zeros, just like that. And it's the same problem as it was before, and I get 12. Okay, let's do another one. Oh, gosh. Basket on my desk. You know, this is life. They're like, can't live without me. 3.6 over 1.2. And so this one, because this is the driver, we have 10. Okay, that's our factor. Our scale factor is going to be times 1. Again, all of these are just being multiplied by 1, so it's not changing the value of our problem at all. It's just changing the look of it. So then I have 36 divided by 12, which is 3. Let's do it again. 0.12. This is the driver. We need 2 zeros. 0.36 times 100. 0.12 times 100. And that means move it 2 places for 36. 2 places for 12. Same thing. Great. 17.5 over 2.5. This is the driver. This means 10. 17.5 times 10, 1 position. 2.5 has only tenths times 10. Move it 1 time, 175 over 25. And you might look at this and go, oh, that's so big. But think about quarters. 4 quarters in a dollar, that's almost $2, but it's just 1 short, so that's going to be 7. Easy answer. 1.75 over 0.25. And this is the driver, so it's by 100. 1.75 times 100 over 0.25 times 100. And that's going to end up being 175 over 25 again. And that's going to be 7 again. So it's the same numbers. We're just looking at where's the decimal, who's the driver, the divisor, or the bottom number, the denominator. So many D words. That's in charge. All right, let's get these word problems done so we can be finished with the day. All right, 15 divided by 3 is 5. Now, your answer is the explanation. Why is it true that 15 tenths divided by 3 tenths or 15 hundredths divided by 3 hundredths all have the same quotient? Now, it's what I've been kind of talking about. It's because look at the ratio. The ratio is always the same, okay? So what does that mean? If it's ones divided by ones, okay, the ratio is the same. It's tenths divided by tenths. It's going to be the same amount of times that it's being divided, or hundredths, THS, by hundredths, THS. Again, the same. So it's that the ratio is not changing. So 15 divided by 3 is 5, but there are still 5 of these 3 tenths in 15 tenths. There's still 5 of them. So you could set it up and do all those practice problems just to prove it to yourself. You really should. All right, let's start with Mr. Volok's problem here. Mr. Volok buys 2.4 kilograms of sugar for his bakery. If he pours 2/10 kilogram of sugar into separate bags, how many bags of sugar can he make? So he's got 2.4 kilograms divided into 2/10 kilo for each bag. So take this and do 2.4 divided by 2/10, okay, and drop off our label so that you can, sorry, it's blurry. So you can just set it up like a fraction. This is the driver, this is in charge. The bottom number, the denominator, says if I have tenths there, I'm going to multiply by 10/10 and move the decimal out of both numbers. If this one doesn't have it, you still have to move that decimal out. Okay? So that's going to give you 12. 24 divided by 2 is 12 bags. Okay, next one. Now, let's say instead of the 2/10, I still have to use the 2 4/10 kilograms. How many bags of sugar can he make? So we still have 2.4, but this time we're dividing it by a different divisor. So take your 2.4 divided by 0.4. And, oops, not equals. Multiply by a scale factor of 1 that will move out the decimal. So that'll give us 24 divided by 4. 24 is a fun number to work with because it has a lot of factors, and that's going to give you 6 bags. All right, let's move on. Next one, almost done. 2 wires, one 17.4 meters long and one 7.5 meters long, were cut into pieces of 3/10 meters long. How many such pieces can be made from both wires? Now, you could spend a whole bunch of time figuring out each one, but why not just put them together? Unless they say separately or exactly specifically from this one, what if this one's blue, what if this one's red, and they say how much from the red one, how much from the blue one, then if they don't tell you specifically to break it apart, you can add them together. So combine and then divide. So when you add with decimals, remember it's been a long time, you have to line them up. We've been multiplying for a while where we didn't have to line them up, and now you have to line them up when you add. Don't forget that. Decimal down. End up with 24 and 9/10. Now that I have 24 and 9/10, I'm going to cut them into these pieces that are 3/10 meter long. Okay, so this is our whole over our divisor. This is the driver. So multiply by 10/10. Move everything one time, 249 over 3. But look, these are both multiples of 3. So that actually is a really easy division problem. You don't even have to write it out for the standard algorithm because 24 divided by 3 is 8 with no remainders, and 9 divided by 3 is 3 with no remainders. So 83 pieces. Okay, pretty soon here I can finish this and get back to my family. Become a subscriber and see what can go wrong tomorrow. Yay, it's so fun. Mr. Smith has 15.6 pounds of oranges to pack for shipment. That's a lot of yummy oranges. He can ship 2.4 pounds of oranges in a large box and 1.2 pounds in a small box. He shipped 5 large boxes. Now, what's the minimum number? That's like the smallest number of small boxes required to ship the rest. Well, first, we have to figure out how many pounds have gone in the large box shipment because he already did 5. So we have to find out how much is left. So let's take the 15 6/10. Sorry. Before we take that, let's figure out how much he shipped in the large boxes. 2.4 pounds per large times the 5 that went. Okay, so these already got shipped. So let's multiply that because it's like repeated addition. 5 times 4 is 20, and then 5 times 2 is 10 plus 2 is 12. Now this is tenths. Just like this when we added it up, this is not like that. This is multiplying, so we do tenths times 1. Ones is tenths. So it's going to be 12.0 or 120 tenths, so 12 pounds already shipped. Okay, very important to kind of keep track of where the products are going. Now what? Now I have my 15.6 pounds that I started with, but I have shipped off 12 pounds. Okay, caution, caution. It's 12.0. It's not 1, 2. Many people are going to mess that up. Watch, just wait till your class corrects this. Okay, 12.0 pounds. Let's take away the pounds that were shipped from the total pounds. 6 minus 0 is 6. 5 minus 2 is 3. 1 minus 1 is 0. Now this is left for the small boxes. So let's take our 3.6, and now we're going to divide it because 1.2 pounds per small box is what we can do here. So 3.6 divided by 1.2, let's make that a fraction and see what happens. This is the driver. Multiply by 10/10, get 36/12, which is 36 divided by 12. And if you count by 12s, 12, 24, 36, even with nothing left over. Bam! And we did that, and it's only 23 minutes, and now I can go see what my family wants and if they're not panicking. So you guys are great. I'll see you on the next video. Bye.